So, hello and welcome, everybody. Hello and welcome to today's special session. We're making up for a session that had a mishap last Wednesday where we couldn't complete. My name is Chris Armbruster. I'm the Director Data Career at the AI Guild, and I'm here today with Tristan Behrens. Hello, Tristan.
Hello, great to see you.
So, I know you as an accredited expert in deep learning, actually accredited by the AI Guild. I also know you as a deep learning specialist with a really strong interest in music composition, but I want to start with the deep learning. I think that's most interesting to our audience. What is it with deep learning and you? You've been doing this for a long time, so what's so
Yes,
fascinating to you?
yes. What's fascinating is that it is not really rule-based. So my background, I did my PhD in artificial intelligence with rule-based agent systems. So you had to sit down and implement everything. And now it's the complete opposite. And this is what I like a lot about deep learning is that it's data-driven. You start with your data and the outcome of your models, how well your models perform, depend on the data that you provided with. Completely different thing. So for me, it's easier because I don't have to sit down and write down all those rules.
I want to follow up on that. So you made a comment precisely about rule-based versus data-driven. Can you expand a little bit? And let's start with the rule-based and your background also with a PhD in AI. So what is it with the rule-based that you think is not necessarily problematic, but where are its limits?
It doesn't scale well. Recently, I talked about composing music with artificial intelligence. And well, this way you see it. It's either rule-based or it's statistical models-based. And with statistical models, if you just want to compose chorales, so church music in the style of Johann Sebastian Bach, it's 300 rules. What if you would like to add another genre to it? What about doing heavy metal? How many rules do you have to write down on top of that? And with deep learning, completely opposite thing. You just provide the model with enough data in the genre, and then there you go. It's way more efficient.
Okay, so there's an additional argument there. It's about the efficiency and actually, so to speak, the outcome that you then achieve that works better. But you also mentioned something about data. So, rule-based system versus deep learning and data quality, but perhaps not data volume. So what can you say about quality and volume?
It's both. It's both. We are trapped in the no free lunch theorem, which translates to that the models that you deploy, how good they are depend on the quality and the quantity of the data. And depending on which kind of use case you try to solve, well, it gives you a couple of numbers like how many samples you need for training and what's the quality. But is the thing. Sometimes it's very rare. Sometimes I have customers that come to me and say, we don't have that much data and the data that we have is dirty. So that's why we want to do deep learning. And then we usually do some requirements engineering and a little workshop about, well, what can you expect? And then it boils down to spending a couple of months getting some data, cleaning data, labeling data, pre-processing the data, and then doing deep learning.
Okay, so there's a certain kind of data intensity there. It
Yes.
also says here music composer, and I know that you've used the COVID downtime, so to speak, to do a lot in this field and actually do some
Yeah.
albums, if I'm aware. So going back to that example of Johann Sebastian Bach, do you have to feed all his music? Do you feed all his music done by different philharmonic orchestras? So this data quantity. So how do you go about this for music?
It depends, again, on the quality of samples you would like to generate. If you just want to do 4-part music, so chorales, where you have 4 singing voices, then you take this tiny little Johann Sebastian Bach chorales dataset with at most 400 songs and you train on that. If you want to go into the fugues and the other things that Johann Sebastian Bach has composed, you have to extend. And also, if you go a little bit further down the road, I think a couple of researchers did it recently with Beethoven. You would not only train on Beethoven's music, but also contemporary music and music that Beethoven has consumed when he was younger. So you can extend on that. But now, where a scaling issue, the biggest data set that is currently available for symbolic music has 400,000 songs, which is quite a lot. I can never listen to all of those. I'm currently training a neural network on those. It's now in its second week of training on 16 GPUs, so I'm quite excited about that. But again, depends on what kind of samples you would like to generate. If it's just shallow, one genre, you need a couple of songs from that genre. If you want to have versatility, if you would like to have a flexible neural network, then you have to feed in more data.
Okay, so you just mentioned that there are some large data sets available that I presume now are also labeled or things have been done with them possibly, because this, data quantity is so quality. Will any MP3 file do? Does the data set need to look in a particular kind of way?
Kinda. What I do is symbolic music, so I don't work with MP3 files. I work with
Okay.
sheet music, where I have the notes
Ah,
already in symbolic form. It makes it a little bit
okay.
easier. It's faster to do the training on that, but also it's a bottleneck because there are only 400,000 songs available in the right format. Everything else is on Spotify as MP3 and WAV files. And I'm still waiting. So if there's someone out there who managed to crack the problem of taking any music file and mapping it to symbolic sheet notation, you would make a lot of people, including me, very, very happy.
Okay, great. So if anybody can help Tristan, please help him. Um, you mentioned that sometimes you have customers that say, we have little data and I'm very sorry, it's dirty. And then you said something about requirements engineering. So one of the other things that you've done over the past years is you've built up your own business that is known actually as AI Guru. Cool name.
Thank you.
Tell us a little bit about that. What do you do?
Hands-on advisory. So my mission is to enable people to actually use and apply deep learning. And it strictly depends on the customer. So I can give you an example. As one of my current customers I met last year, and the first thing we did was a workshop, like hands-on deep learning, just general, like learning a couple of days what deep learning is about. And then we kind of transformed it into now I'm doing research and development with their team. So they have a problem. We build prototypes solving that problem, extend until we have a product. So this is so you already see transformation from just talking about or teaching deep learning and then applying deep learning on their data. And this is just one example. On top of that, a couple of customers are just mentees where we meet every other week and we talk a couple of hours about like their needs, their losses, their sorrows, what they want to learn. So I enable them like that. So that's usually I'm oscillating. Maybe sometimes I'm just doing the teaching and sometimes it's research and development, but usually it was a strong balance the last couple of years.
Okay, so teaching, research and development. You also mentioned product. You said at the beginning hands-on advisory. So do you requirements engineering, but also kind of like technical requirements. So if
Right.
somebody wants to work with you, kind
Yeah,
of be your customer or
yeah,
client,
yeah.
what do you expect from them?
It's the mindset that I expect. And the mindset, it has to be very, very open and very, very open to experimentation. And that's usually the thing that either makes it or breaks it. Um, my customers, they have success when they are open and understand that, well, it's not something that you take off the shelf and then you get a solution after 1 week. At the beginning, especially at the beginning, it's research and development. You have to find out what's the state of the art of what is the state of the art in that use case. What is the quality and quantity of the data? How do the first prototypes perform? How do you do the full circle thingy with data model and deploying to production? Especially at the beginning, it is very, very experimental. And this is something that I require from my customers, that they keep that in mind, that nothing is guaranteed at the beginning. There's a lot of risk at the beginning, but the more you do, and that's the hands-on thing, the more you do, the lower the risk gets because you learn. It's more
Okay.
like comes more from the agile world, that you have to do things in order to find out how well they perform, and then you learn about it and you do it in circles, until you have the product. That's the thing, experimental mindset.
Okay, experimental mindset.
Yeah.
And then you did say a few things that indicate that people should have a machine and be able to use the keyboard.
Yes.
And perhaps use the keyboard to do certain things. So, can you say a bit more about that? So, do you expect skills in Python or SQL, or should people have already seen a neural network or worked with one? How does that look for you?
Um, Technical enthusiasm is the minimum. Yeah, a couple of customers, we started, me and maybe another person doing the first prototypes, and then we built up entire teams. So getting more people on board, and then making sure that the people that got hired or that got onboarded had certain skills. But always there is knowledge transfer. So when I do teaching only, I ask people that they have to feel confident using a keyboard. When I teach, it's usually like yoga, that I do something in front of class and people repeat it, and I make sure that they actually manage the pose. But here it's source code, so I help them developing. So it's more like building personnel, building a skill set. But it gets easier. I mean, the more people are already, well, the more data work they can do, the more programming work they can do, it gets easier for me. But usually all the parties involved learn a lot, especially in the first weeks.
Okay, thank you for that. I have an
Most welcome.
incoming question actually from the audience
Great.
that takes us to also what we want to talk about in a minute. So I'm going to use this also as a bridge. So language models, that actually, as I learned there, when we talk NLP and language models, it's also relevant to music. So something I learned over the past weeks. What is your perspective on OpenAI, its language models, GPT-2, GPT-3, and alternatives to that? That's the question here.
Oh, yes. We are now in the age of the large language models. And yesterday I gave a talk about transformers, and I was amazed to see like what happened in the last few years. Just a quick reminder that in 2017, I think in autumn, we saw the publication of Attention is All You Need, which is a paper about a transformer called the transformer. So nomen is omen. Was a language translation. So one language in, one language out, and then it branched into encoder only models and decoder only models. And OpenAI is known for the decoder only models, the whole GPT family. GPT-3 is it's an architecture size, and it's also a model that they have trained on a huge data set. What I found fascinating is I'm using GPT-3 every day. I'm using it sometimes for writing texts. Most of the time, I'm using it for programming. That's the thing. So I'm programming with an AIs that compose music, and also AIs that solve problems for my customers. So it's so meta. It's unbelievable how meta it is. But also there are other people working on training large language models. Example, Hugging Face. Perfect. They are part of a big science initiative. It's a 1-year workshop with, I think, 400 people involved. And they did a lot of data work at the beginning, so spent a lot of data time. And now they are training a 176 billion parameter large language model on maybe a terabyte of data, text data. I can't remember. It's quite a big number.
Yes, numbers beyond imagination, really, actually, so to speak. Yeah.
It's really, really big. And it's the thing. I mean, I don't know what their plans are, but maybe they're going to open source that. And it's a big difference because, well, GPT-3 is a paid service. So every time I use it for prediction, it charges me a little. It's not that much, but if you write a book with it, it's the money that you would feel. So I'm really looking forward to seeing this model. Also, Elotha AI did some really, really great work and still doing some great work on another set of large language models. There's also European/German initiative for European large language models. They are now also in a phase, I think, where we started practical work. So I'm very happy to see that more and more people are training those large language models, because those large language models, they're extremely powerful.
Thank you for that. So actually, those watching today or viewing this will have a chance to work with you. They will have a chance to work with you hands-on in your usual style that so many people appreciate. At the Data Lift Summit in Berlin from the 22nd to the 24th of June, I think you're going to go live on the 24th of June, that's a Friday, and you are going to be running a workshop entitled Language Generation Using LSTM and GPT-2. So you just spoke about OpenAI, you spoke about alternatives, but there's an alternative also within OpenAI, GPT-2, GPT-3. Can you say a little bit about the difference between the two and why you would like to run your workshop based on two?
Yeah, GPT-2 and GPT-3 are, from a certain perspective, the same. It's the same kind of architecture pattern, but they are different in size. I think GPT-3 has 96 layers and GPT-2 is very, very small. And that's the thing. So what OpenAI did is they started with GPT, and then they published GPT-2, which was a certain size of a neural network and a certain data set, and then they scaled it. Bigger data set, bigger neural network. And well, in order to do a workshop, I mean, that's the thing. A workshop also has to scale. If I would teach GPT-3 from scratch, the workshop would take maybe half a year because I have to, well, we should have to train this GPT, and it's something that is not feasible. It takes computing clusters. So it's trained on supercomputers, where on the other hand side, you could take a small GPT-2 model, and we will do that, and you can train it on collaboratory in a couple of, well, maybe half an hour, maybe 1 hour to get some results. So it's a scalability issue.
Understood. Thank you for that. So it makes the workshop more feasible
Yeah.
and allows participants to actually have a better experience in this sense. Now, the rest of the workshop title is called Language Generation Using Lstm. Now, we love those abbreviations, but here you go. Could you please tell the audience what Lstm is and what it does?
Yeah, no worry. LSTM is not yet the old hat. It's something that you would usually start with when you start doing NLP with deep neural networks, long short-term memory. It's a neural network architecture that has been designed and invented by Schmidhuber and I forgot the other name, by Schmidhuber and his PhD student. It was a neural network. It's a recurrent neural network that can work with sequences of data, and that's the whole thing. A text is a sequence of words. You can process it with that. Trouble with LSTM is they don't scale with long sequence lengths and also with big data sets. And that's why, well, things kind of changed in 2017 with attention is all you need, because now we have long sequence length, maybe 2,000 tokens, which translates to 1,800 words, so long texts, 2-3 pages. And also you can train them on significant amounts of data, terabytes of data. Just takes time.
Thank you for the explanation of the difference. I'm going to go back to the title yet again, and it says here language generation.
Yeah.
So language generation can mean many things. You are going to run a hands-on workshop. What would participants be able to expect?
It's, well, you can use the same architectures, and it translates to LSTM and GPT to generate any language. And the language can be natural language, it can be music language, and it can be programming language. So as long as you make sure that everything exists as text files, you can train the same neural network on it. Neural network doesn't even know if it's training on music, source code, and natural language. So it's roughly the same pattern. The only thing you have to make sure that the data has roughly the same format. So I think in the workshop, we will focus a little bit more on music, but I'm also going to show it how it works with just natural language, and we're going to see it's roughly the same.
That means, so to speak, if the participants join you for the workshop, you've got it set up. You would also have the data sets that people
Yes.
need, and you expect them to basically bring their machine and be able to have the right attitude and a little bit of experience
Yeah.
and be willing to work with you. So after 3 hours, what will they have?
Maybe 1, 2, maybe even 3 Jupyter notebooks with a running implementation of language generation that they maybe can show their family on Christmas.
Okay, that's it's late June then, but yes, I get it. A nice idea. I want to close off today by going back to the very first thing where we said you were an accredited expert in deep learning. And I wanted to kind of invite you, as somebody who's been in the field for a decade now, is recognized as an expert in your fields really very much, to kind of look back a little bit and look forward a little bit in the field of deep learning especially, and
Yeah.
give our audience an idea of what you think have been the major breakthroughs or achievements in the past 2 or 3 years,
Yeah.
and what kind of intuition you have around where this is going in the next years.
Yeah. Things got faster, more complex, but also way more accessible. And let me put this in other words. When I started deep learning, it was like I read a paper one day and next day 2 new papers which were interesting. Now it's last year's one paper today, no, yesterday, and 3 papers now, and it's grown exponentially. So it's very hard to keep track. And myself, it's my business. I'm still hard to keep track. But also the other hand side, things are getting easier. Just giving you an example. When BERT came out, one of those large language models, one of the bigger language models is not so large in comparison because also a couple of years old, I had to struggle like getting it up and running. And now it's very easy. For example, Hugging Face, which is a great company, and they have this the whole software available for you to train and use language models gets easier. And that's the thing, Chris, that you mentioned some minutes ago about the data. When I started deep learning, 80% of the time I spent with data, 20% with the neural networks. Now it's 90-10. And I think it's getting easier. So main focus is data and data representation, data cleaning, and so on and so forth. And then training language models and training other models is just something that now has gotten easier.
Thank you. I have
Okay.
another question come in from the audience here. You mentioned for your workshop that the language could be a natural language, it could be music, but it could also be code. And
Yes.
here comes the question. So, what's your perspective on language models for code generation? And what's your experience with limiting the models to a certain context? So, with contextual limits.
Yeah, it's well, something where my eyes really opened last year when I installed Copilot into Visual Studio Code. Now, I'm a veteran programmer. I started programming in the 1990s, so I know my way around. I'm very fast at finding pieces and putting them together and turning it into running code. This is what I've been doing for decades now. But now there is something that works with me in a sort of dialogue, and it helps me implementing things quicker, significantly quicker. So that when I don't use Copilot, I feel like I'm wading through honey. Like you walk and you have wind coming from the front. And with Copilot, completely opposite. It's like accelerated. So I like this. I'm really looking forward for the next steps. What I'm currently using with Copilot is very, very effective. And I'm really looking forward for the next stages. And the problem with GPT, well, it's not really a problem because it works in production. But still, the whole prediction that GPT-3 does is limited to, I think, 2048 tokens, which is quite a lot of source code, but it's not your entire source code base. Not all you have. It's just a tiny little snippet. And if this grows on, well, even trained on more data, it's going to be even better. But it's hard for me to imagine what would be even better because it's already almost perfect.
Okay, thank you very much, Tristan. So I actually see that for you the outlook is very positive and the future is really bright. Um, it's been a pleasure to talk with you. Thank you very much.
Same here. Thank you very much. It was really great.